Alright, hi guys, welcome back to semester 2. This is Ms. Cooper, and I'm going to go over a few things that have changed for this semester. First thing you'll notice is that when you go into your Schoology account, there's a new schedule. So on Monday, Wednesdays, and Fridays, I'm going to be having office hours from 1 to 2 p.m. and live sessions on Tuesdays and Thursdays from 10:45 to 11:30 a.m. All right, in order to get to those sessions, the links are up here. So what you'll do is you will click the link, and then you're gonna have to enter this code to join the meeting. So what that looks like is you will click here, and then you want to join or start a meeting, and then that's where you're gonna put in that code. And then once you put in the code, you'll be able to start the meeting. All right, this meeting is not started, but anyway, that's how you will do it, okay? The other thing is about your grades, all right? So we are cutting back on the number of graded assignments. So this quarter, you're gonna have 2 graded assignments, but that doesn't mean there's only gonna be 2 things in Schoology. That means that there's 2 things per week that I'll be taking a grade on, but there will be other things in Schoology that you need to complete, and that's gonna count towards your NG hours. So that's more so like your attendance. So 2 things are going to be counted for your grades, but all of the other things inside the Schoology folders are going to be counted towards your attendance. All right, so it is important that you do all of the things in the Schoology folders every week. All right, I think that's it in terms of what is new with our schedule. So what I'm going to do today is I'm going to go over the topic that you guys should have done last week and then talk about the new topic for this week. So just quickly, we're going to recap solving a system by graphing. You want to make sure that you have your Desmos calculator open. So I have a few of them. But you want to be able to go to Desmos. And when you get to Desmos.com, remember go to Math Tools, and we're going to use a graphing calculator. And we're going to be using this today to kind of help us check to see if our answers are correct, all right? So we're going to start here with this system. A system is basically 2 equations, and you should have saw in the video last week that when we graph them, we're trying to see whether the 2 lines meet, where do they intersect across. And that's what we're going to do here. We're going to first graph them by hand, and then we will check in Desmos to see if that matches up. All right, so to graph these by hand, all right, I'm going to start with the first equation. Y is equal to, and it looks like I'm off screen, so I'm going to write it on this side. All right, so if we have y is equal to x minus 8, for this equation, we have a slope of 1, and we make that a fraction, so it's 1 over 1, and then a y-intercept of negative 8. So that means that on our graph, to graph this, our b is the y-intercept, so we're going to count down to negative 8. So I don't know why anyway, it's going to be this point right here, and then we're going to follow our slope, which is 1 over 1. So we're going to go up 1, right 1, and that would be here. And then we're just going to continue that pattern, up 1, right 1, up 1, right 1, up 1, right 1. And that's going to give us this line. So that is the line of the first equation. And then we need to do the same thing with the second equation, which is y is equal to negative 2x plus 1. So this line is going to have a slope negative 2 over 1, and the y-intercept is going to be up at positive 1. So we're going to begin on the y at positive 1. Our slope is negative 2 over 1, so I'm going to go down to right 1. So down to right 1. It'll put me right there. And then I'm going to continue that pattern, and eventually the lines are going to intersect. And then I can see I have a line, and I can see that the 2 lines meet, and so that point where they meet is going to be my solution, and we need to figure out what are the coordinates of that point. All right? And so it looks like the coordinates of this point is going to be at positive 3. And then we go down. Positive 3, 5. And so then that would be the solution. It means that these lines meet at the point 3, 5. All right? So that is how we would graph them by hand, which is what I want you to be able to do. We can also put these into Desmos and check to see if we get the same solution 3, 5. So I'm gonna tap out of this for a second, go to Desmos, and we're gonna see if we get the same answer. So in Desmos, we're gonna just type in our two equations. So we get y is, I think there's a calculator in Desmos. So we're gonna use the keyboard in Desmos. So y equals, I don't know why this won't go down, exit. I don't know what's happening with this keyboard. All right, so our equation was x minus 8. All right, so we're gonna get y equals x minus 8, and you can see that it's graphing that for us over here. And then our second equation is negative 2x plus 1. All right, and so we can see here that Desmos is graphing that for us. I'm just going to zoom out, and zoom in a little bit. You can see here that the lines are going to meet, and then if we click on that point, we said that meets at 3, negative 5, and then we want to check to see is that what we wrote. And we wrote 3, 5, but this is why it's good to put it in Desmos, because it's actually, we go over 3, down 5, so it should be 3, negative 5. So you could use Desmos to graph this and see where the lines cross. Okay. All right, we'll take a look at the next equation. Again, we have the two lines. We can graph them. I'm also just going to run through Desmos real quick so that we can get to the next method. So we can clear these out and type in our equation. So negative 3x plus y. All right, and that's going to graph the first line for us. And then we want to type in our second equation. All right, so now we can see here that the two equations have been graphed, and we can see that they intersect. And if we just click here, this will be our solution. So the solution to these two lines would be negative 5, negative 7, because that's where the two lines meet. All right, so that's just a little bit of review, recap what you guys should have worked on last week, which was graphing. This week we're going to move on to a new method, which is going to be to solve using elimination. All right, when we think about eliminating something, we should think in terms of we want it to go away. To eliminate something means to cancel it or make it go away. And so we're going to do that by combining the two equations. So what I want to happen is that when I combine the two equations, I want one of the variables to be eliminated, meaning I want it to become 0. So we look at our equations vertically, and I wanted to know if I combine the x and y's, would one of them make 0? So if I look, 10 and negative 2, if I add them, will make 8. So that doesn't eliminate. But negative 3 and positive 3 do make 0. So if I add these two equations together, the y is going to be eliminated. So 10x plus negative 2x will be 8x. And then what happens is the negative 3 and the positive 3 cancel and become 0. So that goes away. And this is equal to, we still have to add the two equations together. So 18 plus 6 is 24. So now we have an equation that only has x. So now we can divide by 8 on both sides, and we get that x is equal to 3. Now in order to find the solution, we have to find x and y. So what we can do now is we can take that y value that we just found, plug it back into one of the original equations to solve for y. It doesn't matter which one you choose, so I'm going to choose the first equation. And what I'm going to do is I'm going to take this 3 and I'm going to plug it in for x. So this is going to be 10, and we found out that x is 3. And then I can just solve this. This is going to give 30. And then I want to get y by itself, so I'm going to get rid of this 30 by subtracting it. I'm going to bring down negative 3y. That's going to be negative 12. And then we can divide by negative 3. And so we're going to end up with y is equal to 4. And so now we have x and we have y. So that means that we have our solution. So the solution for this equation would be the coordinate 3, 4. So that means that if I were to graph these two things, they are going to intersect at 3, 4. And so what we can do to verify that is that we can go to Desmos, type both of those equations in, look at the graph and see if they actually intersect at 3, 4. All right? So let's take a look at Desmos and let's do that and see if that's where our lines meet. All right, so remember here our solution was 3, 4. I'm going to go to Desmos, type in my first equation. Okay, so it's going to graph that for us. And then we want our second equation. Right, so we graph these, or Desmos has graphed them for us. We see our two lines, and if we click here, ta-da, we see that the solution is 3, 4, which is the same thing that I got when I solved it by hand. All right, but you need to be able to do the elimination method without Desmos, okay? But Desmos is a tool that we can use to check to see if we are correct. All right, let's go back to the notes and try another example. All right. So what we'll notice here is, again, if we're talking about the elimination method, and if I try to eliminate one of my variables, okay, I'll notice that when I add these two equations together, 4 plus negative 2 is negative 2, and then 2 plus 2 is 4. So this time nothing becomes 0. So what we're going to have to do is we're going to have to change one of the equations so that we do get 0. All right, so there's two ways you can do this. What I see here is that this is a positive 4. So if we can make this a negative 4, then the x's are going to cancel out. So we can do that by multiplying this equation. So we're going to multiply the second equation by 2, and that's going to give us a negative 4x, and then we'll be able to cancel out the x's. So this equation is going to stay the same. And this equation, we're going to multiply it by 2. So we get negative 4x. And you got to be careful, make sure you multiply everything. So everything in here, you multiplied it by 2. And so by doing that, we end up with right here a 0 pair. So that 4x and negative 4x are going to cancel out. And so now we're going to add our equations together. So 2x plus 2y plus 4y will give me 6y is equal to, and then when I add these two together, I get 42. Now I have a very simple equation, so all I need to do is divide by 6, and we're going to end up with y is equal to 7. And then again, once we know the value of one of the variables, we can substitute it in and find the other variable. All right, so what I'm going to do here is I'm going to choose this top equation, and I'm going to plug it in and find x. I'm going to bring this down here. It's going to be 4x plus 2. And I'm going to take out y and plug in 7 equals 6. So this y, I plugged it in right there for 7. So I get 4x plus 14 equals 6. And then we just have a two-step equation. So let's get rid of that 14. And then we divide by 4. So we're going to end up with x is equal to -2. And then once we have x and y, then we write our solution. X is -2 and y is 7. You always have to write your solution as a coordinate. So this will be the final answer that we are looking for, -2, 7. And then again, remember, you can always, on your own, if you want to, pause the video, go to Desmos, type these into Desmos, and check to see, do you get -2, 7? Okay? So again, difference here is they didn't cancel out, so we had to multiply one of the equations to make it cancel out. Okay? All right. Now, because we see and we know that Desmos can do a lot of this for us, what we want to focus on is going to be the word problems, all right? So you can use Desmos here, but there's no equations. So what you're gonna have to be able to do is, you're gonna have to be able to set up your own equations, and then once you set up the equations, then you can solve them or use Desmos, the graphing calculator, to solve it for you. So take a second, read number 7. All right, so if we look at this, we're trying to find the cost of each. So we need to figure out the each what. What are the two things that we are talking about in this problem? All right. So it looks like here we're talking about boxes of envelopes and boxes of notebooks. So you can see here, boxes of envelopes and boxes of notebooks. So those are going to be our two variables. So that's the first thing that we need to do, is identify our x and y. So we're going to say let x equal the envelopes and then we're going to let y equal the notebooks. All right? And so what we're going to do is we're going to write two equations that goes with this story, and then we're going to solve those two equations to figure out what is the cost of each. So it says the cost of 3 boxes of envelopes and 4 boxes of notebooks is $13.25. So 3 envelopes, so that's going to be 3x, and 4 boxes, so adding 4 boxes of notebooks is going to be $13.25. But if you buy 2 envelopes, so 2x, and 6 notebooks, then you're going to get 17. So now we have two equations that we have written. Again, what we can do is we can use one of the methods that we saw earlier, and we can solve that. I'm going to take a shortcut, and I'm going to use Desmos here in order to figure out what is the cost of each. All right, so we know that we have, these are our two equations. So I'm going to go to Desmos. So our first equation was 3x plus 4y equals 13.25. Okay. And then our second equation, they bought 2 notebooks and two envelopes and 6 notebooks for $17. All right, so those are the 2 equations that we wrote. And then we can see here where they meet. So we look right here. This tells us that the solution for this is 115 and 245. So we need to understand what that means. So we're going to go back to the word problem. We're going to write our solution. 115, so that's $1.15 for X and $2.45 for Y. Okay. So the solution was 115 and $2.45. So in our solution, this is the answer for X and this is the answer for Y. And then if we recall how we labeled, that X is going to be the envelope. So that is how much an envelope costs. And then Y was the notebooks. So this tells me that each envelope is $1.15 and each of the notebooks is $2.45. All right, but it's going to be super important that you know how to set up the equation. All right, let's take a look at number 8. Says the cost of 12 oranges and 7 apples is $5.36. 8 oranges and 5 apples cost $3.68. Find the cost of each. So again, the 2 things that we're talking about here are oranges and apples. So we're going to create 2 variables. Let's say that X is going to be the number of oranges and Y is going to be the number of apples. All right, so what we're going to do is we're going to write 2 equations, and those 2 equations we will then use to solve to figure out the cost of each. So 12 oranges and 7 apples. So that would give us 12x for oranges plus 7y for apples cost $5.36. And then we can do the same thing for the second sentence. The second one says 8 oranges, so that's 8x, and 5 apples cost $3.68. And so again, once we have those 2, then you can go back to Desmos, plug that in and find. So go ahead, pause the video at this time and do that. Plug those 2 in, see if you can find the cost of the apple and the cost of the orange. All right, so if you plug those into your Desmos, then you should see where they meet. And so they should meet at 0.26 and 0.32. So I'm gonna write over here. So that should be the answers for down here. So this is your X and this is your Y. So this tells me that an orange is going to cost 26 cents and an apple is going to cost 32 cents. Okay? All right, so you want to make sure that you are able to write an equation, and then you can use one of the methods we saw above, or you can use the Desmos to help you to find the solution. Okay? All right, that's where we're going to stop for today. We will continue and pick back up with this method on Thursday. So check back on Thursday for the second part of the notes. All right, I'll see you guys then.